You've seen the clips on social media. A character walks through a door and suddenly their jawline is wider than it was 3 seconds ago. Most people treat AI video tools like separate, disconnected services, and they think the solution is just writing a better prompt. But in reality, it does the opposite. You're just spinning your wheels. A cinematic movie requires orchestration across 3 distinct systems. We're moving away from prompting for images and moving toward architecting a pipeline. This deep dive delivers the exact workflow, technical constraints, and the model you need to produce professional video that actually holds together. Why AI movies fail: the diagnosis. The character drift problem. Most creators generate a character in one tool and then try to move that person into another model. The moment you hit regenerate, the face changes, and you've lost the very person you were trying to film. This is the character drift problem. It happens because every model uses a different identity embedding, which means there isn't a unified reference system to tell the AI who this person should be across different software environments. You might have a great image from Midjourney, but the video model sees it as a suggestion rather than a strict law that it must follow for every single frame. Seedance 2.0 tries to solve this with a feature called CREF, which stands for character reference, but just clicking a button isn't enough to fix the underlying issue. You have to understand the role-based design principle to get real results. If you upload a cluttered image where the character is holding a coffee cup or standing in front of a complex wall, the model gets confused and can't prioritize what to preserve. You end up with a character whose face is stable but whose outfit keeps morphing into the background texture because the model doesn't know where the person ends and the room begins. The cost of this failure isn't just aesthetic, it's financial. When your character drifts, you usually have to run 3 to 5 failed takes for every single scene, and that means you're burning through credits and wasting hours of your life on iterations that never look right. In a professional environment, this is a disaster because it makes your production timeline unpredictable. You can't tell a client when the video will be finished if you're relying on a digital slot machine to decide if your lead actor looks like the same person from shot to shot. There's also a massive governance gap here that most people ignore. Most teams aren't documenting which specific reference image or seed they used for shot 1 versus shot 5, so when they need to go back and fix a tiny error in the edit, they can't recreate the original character identity accurately. Iteration becomes chaotic. You're basically starting from scratch every time you open the app. This is why you need a master reference pack that stays locked throughout the entire project so that every team member is pulling from the exact same identity data. To fix this, you have to stop thinking about the AI as a magic box and start treating it like a digital asset manager. You create a character sheet with front, back, and side views, and you make sure to use a face close-up on a clean background. By providing these specific views, you give the model the geometric data it needs to keep the identity stable. It doesn't have to guess what the character looks like from a different angle, which reduces the chance of the AI hallucinating new features when the camera moves around the subject. Character drift isn't a model failure, it's an architecture failure. When you don't define the identity anchor clearly, the model fills in the gaps with its own noise, and this is where most AI movies fall apart before they even get to the editing stage. You see it in the eyes first, the spacing changes, the skin tone shifts. Once you understand how these models actually process identity, you can start building a system that prevents these errors before they happen by locking down the variables. Think about how identity actually works in these systems. The model isn't looking at a person, it's looking at a mathematical representation of pixels. When you move from shot 1 to shot 2, that math changes. Without a locked reference, the AI has no reason to stay consistent. It's just trying to make a pretty image based on the new prompt. This is why the old model of prompt and pray is dead. We need a new model based on context and constraints where every pixel is accounted for before you hit generate. The motion artifact threshold. Beyond the identity of your character, there is the massive issue of movement. Higgsfield and Seedance both operate within a very specific range, a limit that most creators don't even realize exists. You see a slider for motion strength, and the natural instinct is to slide it all the way to 10 because you want energy and drama in the shot. But in reality, doing that is destroying your render. This is what we call the motion artifact threshold. It is an implicit boundary where the quality of your output starts to fall apart. If you were to rate motion intensity on a scale of 1 to 10, the danger zone actually starts much earlier than you think. We follow the 3 to 5 rule. When you keep your settings strictly between 3 and 5, the results look cinematic, the movement stays smooth, and the edges of your subjects remain clean. But the moment you cross that 5, the entire logic of the image breaks down. You start to see texture crawling across the screen, the fabric of a character's shirt begins to swim, and limbs start to warp in ways that don't make sense. A hand moves too fast, and suddenly it has 6 fingers. Or it simply melts into the person's thigh. Temporal flicker ruins the lighting because the AI is struggling to maintain the geometry when the change between frames is too high. This happens because the physics in these models aren't real physics. These systems aren't running a rigid body simulation, and they don't actually understand gravity or mass. They are just predicting the next set of pixels based on motion patterns they learned during training. When you ask for extreme speed, the model has to invent too much data from thin air. It is guessing, And when it guesses wrong, you get artifacts. A 15-second clip with high motion complexity is a credit-burning gamble that usually ends in a distorted mess. The consistency paradox. We have looked at character drift and motion thresholds, but now we need to address the consistency paradox. Seedance 2.0 is currently the benchmark for keeping a face stable within a single clip. It is incredibly good at ensuring your protagonist doesn't look like a completely different person by the time they finish a sentence. But here's the problem. This stability is fragile. The model that is best at consistency requires you to supply the exact same reference pack every single time you generate a new shot. It feels like a contradiction, right? You would expect the most advanced model to have a memory, but in reality, it doesn't. Seedance 2.0 lacks a public character ID API like the one found in Sora 2. You cannot just assign a unique number to a face and move on to the next scene. Instead, the system relies entirely on the images you upload and the words you type for every single generation. If you change your prompt to adjust the lighting, the model might decide the character's nose should be pointier than it was in the last shot. This is the paradox. The tool with the highest potential for consistency is the one that requires the highest level of manual discipline from the user. This creates massive workflow friction. You are no longer just a director. You are an asset manager. You have to build and maintain a master reference pack for every character in your script. This pack isn't just one single image. It consists of a front view, a side profile, a back view, and a high-resolution face close-up. You must ensure every single prompt references these exact files in the same order. If you swap the front view for a three-quarter view in shot 5, the identity drifts. The model sees a new starting point and takes that path instead. Most production teams fail here because of a governance collapse. They don't have a system for documenting which reference was used for which scene. You might have 3 different versions of the lead actor on your drive, and maybe one has darker hair while another has a different shirt. If you aren't tracking which one is the North Star, your movie becomes a mess of inconsistent visuals. You will spend half your budget trying to fix these errors in post-production. It is a chaotic way to work, and you are constantly fighting the software just to keep the face the same. The paradox is that the more shots you have in a scene, the higher the risk of failure. In a 10-shot sequence, you have 10 separate opportunities for the character to change. You are playing a game of digital telephone where each shot is a new interpretation of the character. Without a central brain to manage these instructions, the identity eventually breaks. This is why so many AI movies look like random clips instead of a coherent narrative. Practitioners focus on the individual generators instead of the system that connects them. Now, this is important because you need to move one level deeper. You have to replace this manual, error-prone process with a structured orchestration layer. You need a system that sits above the video models and ensures every instruction is grounded in the same set of project assets. This is where Copilot enters the picture as the director of your pipeline. It stops being a tool for writing dialogue and starts being the orchestrator that manages your parametric shot lists and character anchors. Everything changes when you stop managing files and start managing the architecture. And this is the shift. Let's look at how that works. Copilot as the director. We need to stop using Copilot to write scripts and start using it to build systems. Most people think of an LLM as a creative writer, but in reality, it's a structural engineer for your metadata. You're no longer asking it for a story. You're asking it to generate a parametric shot list. This is the difference between a hobbyist and an architect. A generic prompt like "make a cinematic scene" is the fastest way to fail. The model doesn't know what cinematic means to you. It's just guessing. And when it guesses, you lose control of the lighting and the lens. You're basically asking the AI to be the cinematographer without giving it a camera. Everything changes when you apply the 4-layer prompt structure. This is the model behind the director. It starts with the goal. You define exactly what you want the AI to achieve in this specific production phase. Then you provide the context. This isn't just the plot, it's the technical environment of the scene. You set the expectations for the output format, and finally you point it to your sources. This structure forces Copilot to stop being creative and start being precise. You're giving it the boundaries it needs to function as a director. It's about grounding the AI in the reality of your project files instead of the vast randomness of its training data. Now, let's talk about parametric language. This is where the real power lives. The parametric prompt framework. To build a movie that doesn't fall apart, you need a framework that defines every single variable. This isn't about being poetic, it's about being mathematical. We use a structure that covers the subject, environment, action, camera, lighting, style, and continuity constraints. This is the blueprint that keeps your production on the rails. Most creators fail because they leave too much to chance. They hope the model will understand the mood, but hope isn't a production strategy. You need to specify the exact parameters for every frame. Let's look at the subject first. Instead of saying a man, you specify a man in his 40s wearing a charcoal gray tactical turtleneck and rimless glasses with a distinctive scar on his left cheek. You're building a character anchor that never changes. You're giving the AI a physical checklist. Then you define the environment. You don't just say office. You describe a modern minimalist office with floor-to-ceiling windows during the late afternoon golden hour. You're setting the physical boundaries of the scene. You're telling the model exactly how the light should interact with the glass and the surfaces. The action should be just as specific. You might describe a slow walk toward the window, a brief pause, and then a turn to the camera with a concerned expression. This tells the model exactly what to prioritize in the motion. It prevents the AI from adding random gestures that break the immersion. But here's where it gets interesting. The camera settings. You aren't asking for a cool shot or some cinematic vibe. You're instructing a slow dolly in on a 35mm lens, starting at a wide shot and ending at a medium close-up. You're talking to the AI like a technical camera operator. You're defining the optics and the field of view. Lighting is the next layer. You specify a key light from the window at 5600 Kelvin, a soft fill from overhead, and a rim light from the background. By using Kelvin values and light positions, you remove the ambiguity that leads to flickering or inconsistent shadows. You're defining the color temperature of the scene. Then you add the style. You want it photorealistic with film grain and slight desaturation, matching the color grade from the previous shot. You're ensuring that the look of the movie stays identical across every single scene. You're telling the AI that the aesthetic is a fixed constant, not a variable. Finally, you include the continuity constraints. This is the most overlooked part of the process. You explicitly state, same character as shot 1, same outfit, same lighting temperature. This tells the model that it doesn't have permission to innovate. It must stick to the existing data. Every parameter in this framework is measurable and reproducible. There's no room for the model to interpret your vision because you've already defined it. This is the shift from creative guessing to technical execution. You aren't just making a video, you're configuring a render. This framework becomes your master instruction set for the entire pipeline. It's the bridge between Copilot's planning and the actual generation in Seedance and Higgsfield. When you work this way, you stop being a prompt engineer and start being a systems architect. You're building a repeatable process that produces predictable results every time you hit generate. You're creating a language that the AI understands perfectly. This is how you scale a production without losing control of the quality. It's about moving from a world of what if to a world of this is. And once you have this framework locked, you can move into the project assets. It's the model behind the movie. Grounding Copilot in your project assets. You have the framework, but a framework without your specific project data is just a hollow shell. Most people fail because they let the AI pull from its general training data, and that is exactly where the story falls apart. You need to use the sources layer. This is where you point Copilot to your actual script and your storyboards. You aren't letting it guess your story. You're giving it the exact blueprint. It is the difference between a stranger guessing your brand and a team member who has read the manual cover to cover. You do this by using the file upload feature or the SharePoint integration. When you ground the AI in your project, it stops looking at the internet for answers, and the result is that it starts looking at your specific color palette. It follows your brand guidelines. It reads your character descriptions word for word. This is how you ensure that the man in his 40s we talked about earlier actually looks like your lead actor. You are providing the context that prevents the model from wandering off into generic territory. There is a massive governance benefit to this approach. Every shot list that Copilot generates becomes traceable. You can audit the output because it is linked to the source document. If a shot feels off, you can see exactly which part of the script the AI was referencing. This creates an automatic audit trail for your production. You aren't just getting a list of shots. You're getting a configuration that is verified against your project assets. It makes the entire iteration process transparent and accountable for everyone. Think about the risk of drift. When you're making 20 shots, the AI usually forgets what happened in the first one. But when Copilot references your master character sheet, that drift stops. It won't describe your character differently in shot 10 than it did in shot 1. It pulls from the same fixed descriptors every single time. You're using the AI to enforce your own rules. It becomes the gatekeeper for your continuity. This is the model that separates professional pipelines from amateur experiments. You're essentially using the AI as a compliance officer for your own creative standards. The workflow is straightforward. You let Copilot generate the shot list based on your uploaded assets, and then you review it to make sure the technical parameters look correct. Once you approve it, that list becomes your North Star. It is the master document for Seedance and Higgsfield. You're no longer typing unique prompts into every tool. You're copy-pasting the parametric instructions that were already vetted against your script. Everything stays connected because the source of truth is centralized in your project files. This ensures that every department is working from the same sheet of music, even if those departments are just different AI tools. This level of grounding is what makes the orchestration layer work. You're building a closed loop where the AI only knows what you tell it. You've removed the randomness. You've replaced it with a technical instruction set that is physically grounded in your creative intent. The transition from the planning phase to the generation phase becomes easy. Now that you have a parametric shot list backed by your project assets, you're ready for the next stage. You need to translate that list into consistent character generation. This is where the architecture moves from planning into actual visual construction. The role-based reference design, Seedance 2.0, changes the way we think about visual input. It doesn't treat every image you upload as an equal suggestion. Instead, it assigns a job to every piece of media. This is the role-based design principle. If you don't understand this, your character will never stay stable. Most people upload one good picture and hope for the best, but in reality, that is why it breaks. You're asking one file to do 4 different jobs. It has to define the face, lighting, background, and clothes. That is too much data for the model to prioritize. You need to separate these into 4 distinct roles: identity, pose, environment, and style. Identity is the most critical. This is the geometry of your character. To get this right, you need a set of clean references. You want a front view, a back view, a side profile, and a high-resolution face close-up. These need to be on a plain white background. If your character is standing in a forest in their identity shot, Seedance might decide the forest is part of the character's skin. You want zero clutter, just the subject. Now, let's talk about a major hurdle for practitioners: safety filters. Seedance is incredibly aggressive about real human faces. If you upload a photo of a real person, it usually gets blocked. It is a safety mechanism to prevent deepfakes. But there is a workaround. We use AI-generated faces that look human but don't trigger the block, and this allows us to maintain the identity without the system shutting us down. You are essentially creating a digital double that the safety filter accepts as a synthetic asset. This keeps your pipeline moving without the constant frustration of rejected files. The answer tag system and prompt binding. Once you have your reference pack ready, you need a way to tell the model exactly how to use it. Seedance 2.0 uses a specific syntax called the A tag system to handle this. You aren't just uploading files and hoping the AI figures it out on its own. Instead, you are explicitly binding each file to a specific function in your generation. It works a lot like mapping a controller in a video game. You are telling the software that @img1 is the face, @vid1 is the motion, and @audi1 is the rhythm. If you skip this step, the model treats your uploads like a vague mood board. It might accidentally use the lighting from your face shot for the background, or it might use the motion of your character reference as a style cue for the clouds. This is where things get messy. Without binding, you lose control over the output. The syntax itself is simple. When you write your prompt, you use @img1 for identity, @vid1 for the camera path, and @aud1 for the pacing. The magic happens when you turn these into constraints. Instead of saying make him walk, you tell the system to use @img1 for character identity and @vid1 for the motion and camera path. Now the AI isn't guessing anymore. It is executing a specific set of rules. This is the discipline that separates high-end production from casual experimentation. Every prompt you write becomes a configuration document. It isn't a creative writing exercise anymore, but a technical spec. This is important for governance because a prompt using @tags can be audited later. You can look back at shot 1 and shot 10 to see that they both used the same @img1 reference. This ensures that the character stays locked. If you swap references between shots, you introduce a consistency risk by telling the model to change the starting math. Let's look at a practical example. In shot 1, you use @img1 as your front view, and in shot 2, you use the exact same @img1 tag. Even if the camera angle changes, the identity anchor remains the same. This is how you keep the face stable across a whole scene. You are using the same identity data for every single render. Most people make the mistake of using a different image for every shot because they think a side view needs a side reference. But here's the thing, that just gives the AI more chances to drift. You want the model to infer the side view from your master identity anchor. This binding process creates a versioned history of your character. You can see exactly which configuration produced the best results. If shot 5 looks great, you copy that exact prompt structure for shot 6 and just change the action description. The @tags and the references stay the same. This is the model behind the consistency. You are building a library of configurations that you can reuse across the entire movie. It is about moving from a world of manual tweaks to a world of systematic execution where your prompt is the code that runs the pipeline. But here's the problem with the old way. People used to just throw images at the box and hope for the best. When you use the ads tag system, you are creating an explicit link. You are saying that this specific file ID is the only source of truth for this specific attribute. It is a binding contract. If your prompt says to use @img1 for identity, the model is forced to ignore the identity cues in any other uploaded images. This prevents the identity argument that usually ruins AI video clips. It is the difference between a suggestion and a command. And one level deeper, it allows you to version your character. If you update @img1, you know exactly why the character changed in the next render. You are managing the data rather than just the output. This is the shift toward a professional architecture where every pixel is traceable back to a tag. Now you need to manage the motion complexity. Character consistency within and across clips. You have to distinguish between holding a face together for 2 seconds and holding it together for 2 minutes. Seedance 2.0 is designed to maintain a character's face for about 1.5 to 2 seconds of active motion before the internal math starts to wander. This window is your limit. It represents the boundary of the model's current temporal memory. If you try to push a single generation to 10 seconds without cuts, you will watch the features melt as the system tries to reconcile new movements with old pixel data. It is the model's physical constraint. Success within these short bursts depends on your starting conditions. You should use neutral lighting across every reference image because the model interprets shadows as permanent physical features. If your character has a heavy shadow on their cheek in the reference, that shadow will swim around their face like a bruise when they turn their head. Stick to simple actions like sitting or walking while keeping the backgrounds plain to minimize the amount of data the AI has to track. This simplicity protects the render from failing. Scaling this to a full scene requires a different kind of discipline. You must reuse the exact same reference pack and style anchor for every single prompt in that sequence. Most people think they should update the reference to match the new shot, but that actually forces the model to recalculate the identity from scratch. By keeping the inputs identical, you ensure that the AI is always pulling from the same mathematical base, which keeps the character's bone structure and features from shifting between clips. Understanding motion strength and the artifact threshold. Higgsfield hides the raw numbers from you. You won't find a dial labeled motion strength that goes from 0 to 100. Instead, the system gives you camera presets like arc, dolly, or crash zoom. Every one of these choices carries a hidden level of aggression that the engine applies to your scene while it tries to calculate the next set of visual data. To keep your output stable, you need to assign your own mental rating to these presets. Think of it as a scale from 1 to 10. If your goal is to maintain production quality, you want to land between 3 and 5. When you drop below a 3, the footage feels frozen and loses that cinematic weight because the movement is too subtle to register as a professional camera move. But the real danger lives on the other side of the dial. Once you push past 5, the AI feel starts to bleed through the pixels, and that is exactly where the illusion of reality collapses. You will see textures crawling on the walls or limbs that warp during a turn, and these glitches happen because you have crossed a technical boundary. Under the hood, models like Sora or Kling do not actually know how the physical world works. They aren't calculating the mass of an object or the way light should bounce off a moving surface, but are instead making probabilistic guesses about what the next set of pixels should look like. When you ask for high motion strength, you are forcing the model to invent massive amounts of new information for every single frame. The engine has to hallucinate geometry and lighting at a speed that exceeds its internal logic, which causes errors to compound with every millisecond of footage. These systems use learned motion patterns instead of rigid body simulations. In a traditional 3D engine, the computer knows exactly where every joint is at all times. But in generative video, the AI is painting a new picture 24 times every second. If the movement between frames is too large, the brushes start to miss their marks, and this is why a hand might grow an extra finger or a face might shift its proportions during a fast zoom. The model is trying to reconcile two vastly different states without a physical map to guide the transition, and that leads to the warped visuals we see in bad clips. This technical limitation has a direct impact on your iteration budget. If you try to render a 15-second clip with high motion complexity, you'll probably fail 3 times before getting one usable take, and every failed generation burns credits that could have been used for final shots. Orchestration helps you avoid this waste by designing your scenes to stay within the stable threshold from the start. You learn to favor gentle arcs and slow dollies because they respect the mathematical limits of the technology while it is still in these early stages of development. Staying in that 3 to 5 range is the secret to cinematic realism. It provides enough energy to keep the viewer engaged without triggering the artifacts that scream generated content. You are looking for smooth transitions where the edges of your subjects remain sharp and the lighting stays consistent. When the motion is controlled, the AI can focus its compute power on maintaining character identity and environmental detail throughout the duration of the shot. You aren't just making a video, you are managing the entropy of a probabilistic system. You must align your shot design with these technical constraints. If your script calls for a high-speed chase, you shouldn't try to capture it in one continuous wide shot, but should instead break it into smaller segments with moderate motion settings. This approach allows you to maintain a high level of detail while still delivering the sense of speed your story requires for the audience to feel the tension. You are using the architecture to work around the flaws of the model. Camera motion presets and cinematic language. Higgsfield offers more than 60 camera presets. These aren't just creative suggestions. They map directly to the traditional language of cinematography, and you need to understand this vocabulary to truly control the output. If you don't speak the language of a director of photography, you are just clicking buttons and hoping for a good result. That assumption is what leads to messy renders. Take the arc right or arc left movements. These presets create a gentle circular path around your subject and are effective because they add depth without overloading the model's processing capacity. Then you have the dolly in and dolly out, which are classic moves for building tension or revealing a scene by moving the camera physically toward or away from the character. Because the perspective shift is linear, the AI can usually maintain the geometry of the face without much trouble. But then things get more aggressive. You have the crash zoom, which is that fast zoom used for shock or sudden emphasis, and it represents high motion strength. That means it carries a high risk of creating artifacts. The handheld preset adds subtle jitter and micro movements to make a scene feel intimate, almost like a documentary, but that jitter can also amplify any existing flickering in the background textures. In a professional edit, that jitter needs to be motivated by the story, so you don't just add it because it looks cool. You add it because you want the audience to feel like they are standing in the room with the executive. The orbit preset is even more complex. It is a 360-degree rotation around the subject. And because the camera is moving so much, the AI has to reinvent the entire environment constantly. This is a high complexity move with a massive risk of warping. Then you have the crane up and crane down, moves that rise or fall to reveal the environment. Finally, there is panning, which is rotating the camera left or right on a fixed point. It is simple, low risk, and rarely produces artifacts because the perspective shift is minimal for the engine to calculate. The real strategy for a practitioner is to start small. For your first pass, you should choose the gentle presets, like the arc, the slow dolly, or the pan. You want to lock in a stable character and a clean environment before you try anything fancy. Once you have that foundation, you can start layering in the more complex moves, but you don't try the orbit until you know the character identity is solid. You also need to be explicit in your prompts. You don't just select a preset and walk away. You write the motion into the instruction set. You might say, slow dolly in at 0.3 meters per second, subtle handheld jitter, 35mm lens, shallow depth of field. This is parametric instruction, and it prevents the model from guessing what you want. It removes the ambiguity that leads to those weird morphing errors. When you specify the exact speed and lens type, you are telling the AI how to spend its compute budget. You are giving it a physical limit, and this is how you bridge the gap between a generic AI generation and professional cinematography. You are using the presets to define the path, but you are using the text to define the optics. It is a dual-layer control system. Everything changes when you stop asking for movement and start demanding optics. You are no longer at the mercy of the model's random interpretation because you are now the architect of the shot. You are using the presets as a framework for your own technical requirements. This is the model behind the motion. It is about moving from a world of presets to a world of parameters. You are essentially defining the physics of the lens before the pixels are even drawn. This level of precision is what separates a professional pipeline from a hobbyist experiment, and it ensures the camera behaves like a physical object in space. Motion reference and character interaction. The architecture becomes powerful when you stop relying on text to describe movement. Higgsfield uses a feature called motion control to solve this specific problem, and it uses the Kling models to bridge the gap between imagination and the physical reality of the scene. You can capture motion from the real world and map it onto your digital subject. This is the shift from prompting to performance. Instead of typing a description, you are providing a skeleton, which removes the guesswork that usually leads to those weird limb warps. You are essentially giving the AI a set of physical rules to follow. The workflow is simple, but requires a high degree of precision to work. You film yourself or a stand-in actor performing the specific action required by your script, and this video becomes your primary motion reference for the engine. Seedance 2.0 handles this through the video reference tag, so you just use that at vid1 syntax. You upload your performance and tell the model to use it as the structural guide. This ensures that the timing of a head nod or the rhythm of a walk is physically grounded. You are not asking the AI to guess how a human moves, because in reality, you are showing it. This method provides a level of control that text prompts cannot match. Everything changes when you provide a real example instead of asking the AI to invent physics from scratch. When you rely on text alone, the model has to hallucinate the weight and momentum of a body. But with a motion reference, you are giving it a map of joint positions and timing. The model extracts the skeleton from your video and applies it to your character's geometry. This is important because it preserves the nuances of human behavior that an algorithm might miss. You get believable hand gestures and body language that feel earned. It solves the problem of floaty characters who do not seem to have any mass, but here is where the model breaks if you are not careful with your choices. The proportions of your reference actor must roughly match the proportions of your AI character. If your character is tall and slim, but your reference actor is short and stocky, the math will not align. You will see the limbs stretching or the shoulders warping as the AI tries to force a large frame onto a small skeleton. You need to align the physical profiles to maintain the integrity of the render. This is a technical constraint that requires foresight during the pre-production phase. You cannot expect the model to fix a fundamental mismatch in body types, and it is your job to ensure the source data is compatible with the target character. Governance is the final layer of this motion architecture. You must document which specific motion reference was used for every individual shot in your production, and this information becomes a part of your audit trail for the project. If a shot needs to be regenerated 3 months from now, you need to know which video provided the skeleton. It makes your iteration process reproducible and scalable across a larger team. You are treating your motion references like any other technical asset in your pipeline. This level of documentation prevents the chaos of lost files and forgotten settings. You are building a library of performances that can be audited and reused, and it ensures that your production standards remain consistent over time. Combining character consistency with motion reference gives you a level of cinematic realism that was impossible a year ago. You are no longer just generating clips, you are orchestrating a performance. You have the face locked with Seedance and the movement locked with Higgsfield. This dual-layer approach ensures that your protagonist looks and moves like a real person in every single frame. You have built a pipeline that respects both identity and physics. Now you need to manage the full integration of these tools into a single production workflow. The 3-tool workflow. We have broken down the individual components of the stack, but a collection of tools is not a pipeline. You need a sequence that turns ideas into a finished film. This is the 3-tool workflow. It is a linear process that moves from metadata to pixels to motion. If you skip a step or change the order, the architecture collapses. You end up with shots that do not match and characters that drift. Most people try to do everything in one box because they want one tool to be the director and the actor, but in reality that is why they fail. You must separate the logic from the rendering. Step 1 starts in Copilot. You are not asking it to be creative, but you are using it to generate a parametric shot list. This document must include explicit camera settings and character anchors. You want every shot to have a technical description that leaves zero room for the video model to guess. Once you have this list, you move to step 2. You create your master reference pack in Seedance. This is where you assemble your identity shots and your style anchors. You are building the visual ingredients before you start cooking. This preparation phase is where consistency is won. Step 3 is the actual prompting. You take the parametric data from Copilot and the ad tags from your reference pack, and you combine them into a single instruction set for Seedance. You tell the system to use at image 1 for the face and follow these 35mm lens settings. This ensures the output matches your original vision exactly. By the time you reach this stage, the AI is not making creative choices, but it is executing a technical plan you have already built. This is how you maintain control over the final image. When the logic is separated from the pixels, the results become predictable. That is the goal of a professional workflow. Handling character drift and consistency failures. Things will go wrong. Even when you follow the workflow perfectly, you will see the character start to unravel. This is where you stop being a creator and start being a forensic investigator of your own data. The first symptom you will probably see is subtle face morphing across frames. Maybe the jawline gets a bit wider or the eye spacing shifts by a few pixels during a head turn, and because it happens slowly, you don't notice it until you watch the playback and realize something feels fundamentally off. The root cause is usually inconsistent lighting in your reference images, or you simply pushed the motion complexity past that threshold we discussed earlier. To fix this, you need to tighten the reference consistency. You should use images from the same session with identical lighting so the model isn't trying to merge two different environments, or you can just reduce the motion complexity until the geometry stabilizes. Then there is the outfit problem. You generate shot 3 and suddenly the executive's turtleneck is a different shade of gray or the fabric texture starts to shimmer and crawl. This happens because your style references are weak or your prompt is overloading the model with conflicting style instructions. If you tell the AI to be cinematic and moody while also providing a bright reference image, it gets confused. It starts to interpolate between the two states. The fix is to use a single, strong style anchor image. You repeat the exact same style descriptors in every single prompt because you aren't giving the model room to innovate on the wardrobe. That innovation is actually just drift. The most jarring failure is when the character looks like a completely different person in shot 3. You look at the eyes and the bone structure, and it's just not the same executive anymore. This isn't a model glitch, it's an orchestration failure. You probably swapped out a reference image or changed a character descriptor between the two shots, and even a small change in the wording can trigger a different latent representation in the model. You prevent this by using a character anchor document. This is a fixed list of every descriptor for every shot. You copy-paste those words. You don't rewrite them for a specific angle. You use the exact same data to ensure the exact same result. Sometimes the identity is stable in Seedance, but breaks the moment you move to Higgsfield for motion. Higgsfield's rendering engine interprets facial features differently than Seedance does. It's a multi-tool limitation. The motion rendering can shift subtle details like the bridge of the nose or the curve of the lips. When this happens, you have 3 choices. You can reduce the motion complexity to give the engine less work, or you can use a gentler camera preset. The third option is to accept the minor drift and correct it in post-production. It ensures you stay in control. You have to check your inputs before you blame the model for failing you. Most consistency issues are actually operator errors, not technical bugs. You might have left a stray word in your prompt or used a reference with a different focal length. The AI is just a mirror of the data you provide. If the data is messy, the render will be messy. Governance is about making sure the inputs are clean before you hit the generate button. You are managing the instructions. You are the one responsible for the continuity of the scene. This mindset shift is what allows you to move from a lucky take to a production-ready sequence. Once you understand these failure modes, you can build a plan to prevent them. Building a shot-by-shot production plan, you need a way to track the chaos. When you're managing 20 different shots, your memory is the first thing to fail. You need a production Bible document. This is a shared space in SharePoint or Notion that tracks every single decision you make before you touch the generation engine. It's the single source of truth that prevents your character from looking like a stranger by the time you reach the third scene. If you aren't documenting the configuration, you aren't doing production, you're just gambling. This is where the system starts to work. Let's look at the structure of this document. You need specific columns to maintain control. Start with the shot number and the scene name. Then you list the camera movement. Using the technical language we already explored, you need a column for the character descriptor. This is the exact text block you copy and paste into every single prompt. You include the reference pack column to list your @tags for every file. Then you add the motion strength and the model choice, whether it's Seedance or Higgsfield. Finally, you have a status column to track approvals. The discipline here is non-negotiable. You have to fill out this document completely before you generate a single frame. This forces you to think through the camera language and the motion complexity while your brain is still in planning mode. It stops you from making impulsive creative choices that the models can't actually execute. You're building a roadmap for the AI to follow. Without this structure, you're just guessing, and guessing is what leads to the character drift we just talked about. When you have the production Bible ready, you aren't just clicking buttons and hoping for the best. You're executing a strategy. This document is what separates a hobbyist from a professional workflow. It keeps the project on track when the complexity starts to scale. And most importantly, it gives you a way to troubleshoot when things go wrong. If shot 5 looks different than shot 4, you go back to the Bible and find the discrepancy. The answer is always in the data. Credit economics and iteration budgeting. Every time you hit the generate button, money leaves your account. Seedance 2.0 on an Ultra plan costs roughly 35 cents for a single high-quality generation, which sounds cheap in isolation until you look at the bigger picture. Rendering video in Higgsfield varies based on the model you choose and the resolution you're targeting, but you're generally looking at somewhere between $1 and $3 per minute of output. The math compounds quickly when you start thinking about a full production. Let's work through a concrete scenario to see how this adds up. You're building a 60-second scene with 10 shots, where each shot goes through Seedance first for character consistency and then potentially through Higgsfield for motion. The Seedance cost is $3.50 total, but the Higgsfield cost for 6 high-motion shots lands somewhere between $10 and $30 depending on your model selection and resolution tier. That's a single iteration at $13.50 to $33.50 per scene. If your references are weak or your motion settings are too aggressive, you'll need 3 iterations minimum to get a usable result, meaning you're now spending $40 to $100 on a scene that might have taken 2 weeks of traditional shooting. This is where the architecture becomes financially critical. Most practitioners don't understand that iteration cost is a hidden multiplier on the base generation cost, and they think they're just paying for rendering when they're actually paying for their own indiscipline. Every regeneration because of character drift is a tax on poor reference management, and every regeneration because of texture crawling is a tax on motion settings that exceeded the threshold. These aren't unavoidable costs. They're the penalty for not following the workflow correctly. The governance angle here is measurement. You need to track cost per shot and cost per iteration across your entire production, because this data reveals the pattern of where your process is breaking down. If you're consistently burning 3 iterations per shot, that tells you something specific is wrong with your inputs. Maybe your references have inconsistent lighting, or maybe you're pushing motion complexity too high, or perhaps your parametric prompts aren't clear enough. The cost data acts like a diagnostic tool that shows you exactly where discipline is leaking out of the system. The practical rule is simple but requires real restraint. When a shot fails, your instinct is to hit, generate again with a small tweak, but you need to stop and review your inputs first. Pull up the reference images and look for lighting inconsistencies, then check whether the motion strength matches the action in your parametric description. Read your prompt line by line to see if there's conflicting instruction hidden in the text. Maybe your ad tags are pointing to the wrong image, or you accidentally changed a character descriptor that should have been fixed across all shots. This discipline takes maybe 10 minutes to execute. But that 10 minutes of debugging prevents a $20 or $30 regeneration, and across a 30-shot production, that's the difference between a $200 generation budget and a $500 budget. The math works in favor of patience. You adjust the reference to match your lighting anchor, you reduce the motion strength from 5 to 3, and you simplify the scene by removing a busy background before you regenerate. This approach also teaches the system something about your aesthetic. If you're forcing Higgsfield to render high-complexity motion and accepting the artifacts, you're training yourself to lower your standards. But if you refuse to accept a bad render and instead tighten your inputs, you're training your instinct. You start to see which combinations of references and motion settings produce clean output on the first pass, which makes your first pass approval rate climb and your cost per finished minute drop. What looked like a technical limitation becomes a design constraint that sharpens your creative choices. Managing credits is fundamentally about managing discipline. It's about accepting that this tool has boundaries and designing your work to respect those boundaries instead of fighting them. When you do this consistently, the architecture pays for itself in reduced iteration and faster throughput. Now you're ready to scale this single scene workflow up to a full production, which requires a comprehensive plan that coordinates character consistency across multiple scenes. The multi-shot narrative and continuity. A scene isn't one shot, it's a sequence. When you're assembling 3 to 10 shots into a single scene, you're building a narrative moment that the viewer experiences as continuous time and space. But here's the structural problem. Each shot is generated independently. The AI doesn't know that shot 2 is supposed to be the same character as shot 1 from a different angle, so every time you hit generate, you're asking the system to invent the world from scratch. This means drift compounds with every additional render. By shot 5, your character might look subtly different, and by shot 10, they might look like a different person entirely. The solution starts with a different mindset. Instead of treating each shot as a standalone creative moment, treat it as a configuration variation. You use the same master reference pack across every single shot in the scene, which isn't a limitation but rather your control mechanism. When you reuse the same identity images and the same style anchors, you're anchoring the AI to a fixed baseline. The model knows it's working with the same visual data, so it doesn't need to recalculate who the character is. The practical workflow is straightforward but requires absolute discipline. You generate shot 1 using @img1 for your front reference, @img2 for your back view, and @img3 for your side profile, while including a specific lighting anchor and a color palette descriptor. Now for shot 2, you use the exact same @tags. You don't think, oh, shot 2 is a close-up, so I'll use a different reference. You use @img1 again. The only thing that changes is the camera angle and the action in your parametric description. The model is working with identical identity data, but the framing is different. And this consistency in inputs produces consistency in outputs. For shot 3, you use the same approach. Same @img1, @img2, @img3. Same style anchor, same lighting temperature in your descriptors, different camera movement, different action, same character. When you're done rendering all the shots, you play them back in sequence and look for drift. You're watching for subtle shifts in skin tone or eye spacing, and you're listening for consistency in the character's voice if there's dialogue. You're checking whether the outfit maintains its color and fabric texture across the cuts. What you'll probably notice is that some drift is inevitable. The jaw might look slightly wider in one shot, or the eyes might sit fractionally closer together in another, which is simply the artifact of regeneration and the cost of using probabilistic systems. You have 2 options. First, tighten your references further. Maybe your lighting references have shadows that the model is interpreting as permanent facial structure, or your style anchor has color information that's pulling the render toward a slightly different skin tone. You audit your input files for inconsistencies and try again. Second, you accept the minor drift and plan to color correct it in post-production by adding a small correction pass in your edit timeline to smooth over the subtle transitions. The governance piece is critical here. You must document which shots have acceptable drift and which ones require regeneration, because this becomes part of your quality standards. If eye spacing shifts by 2%, that might fall within acceptable bounds, but if it shifts by 10%, that's a regeneration trigger. You're defining the boundaries of what passes as continuity for your specific project, and this documentation then becomes a template for future scenes. You build standards that your team understands and applies consistently. This approach also prevents a common mistake, overshooting. When creators see drift, they instinctively try to fix it by generating more and more takes of the problematic shot, but what they should be doing is examining whether the references themselves are the problem. If shot 5 shows drift that shot 1 doesn't, the difference isn't random. It's because something about the inputs changed. Maybe you adjusted the prompt language slightly, or you're fighting against a different background environment. The drift is diagnostic, and it's telling you where the configuration broke. Multi-shot continuity is the foundation of scene-level production. Once you master this, you're ready to think about larger problems like coordinating character consistency across multiple scenes where the character changes their outfit or the lighting environment shifts dramatically. That's where the architecture scales up. You move from managing consistency within a scene to managing it across an entire narrative. Scaling to full scenes and multi-scene productions. You've mastered the single scene, and you finally know how to keep a character stable across 10 shots using parametric prompts and consistent references. But a real production isn't just one scene. It's usually 3 to 5 scenes, each with its own set of 10 shots, which adds up to somewhere between 15 and 50 shots across a full narrative arc. This is exactly where most productions fall apart. The challenge isn't the technical difficulty of any single shot, but rather the coordination of consistency across a much larger canvas where your character might change their outfit, age slightly, or move through completely different lighting environments. At this scale, managing consistency requires a different organizational system. You need a master character document for every distinct character in your film. This isn't the same as the character anchor document you use for a single scene because this is a library. It contains every reference image you've created for that character across all scenes. It catalogs all the variations like front, back, side, and close-up faces, but it also tracks variations for different lighting conditions and different wardrobe states. If your executive is wearing a charcoal turtleneck in scene 1 but switches to a blue dress shirt in scene 2, you need separate reference packs for each outfit state. The master character document links to all of them with precise version control so you never lose track. The discipline here is absolute documentation of change. Every character transformation must be recorded with a date and a specific reason. If your character gets a haircut between scene 1 and scene 2, that change lives in the document. Future team members, or even your future self, can look at that entry and understand that the shorter hair is intentional rather than a consistency failure. They'll pull the correct references for scene 2 and onward. This prevents the chaos of wondering whether the character was supposed to change or whether you just made a mistake 3 weeks ago that nobody caught until now. Linking this master character document directly into your Copilot prompts is the next step. When Copilot generates your shot list for scene 3, it can reference the exact lighting anchors and character descriptors that apply to that specific scene. This prevents Copilot from accidentally describing your character differently in shot 25 than it did in shot 8 because both prompts are pulling from the same source file. The AI becomes a tool that respects your constraints instead of acting like a creative free agent. Every shot list stays consistent because the input data is consistent. Before you generate a single frame in a new scene, you need to create a scene checklist. This is a rapid reference document that lists every character appearing in that scene, every reference pack that applies to them, and every continuity constraint you need to respect. If your character's outfit changed in scene 1, the checklist reminds you not to revert to the old wardrobe by mistake. If the lighting shifted from tungsten to daylight, the checklist flags exactly which reference images to use. You review this checklist before you prompt Copilot, and you check it again before you prompt Seedance. It catches mistakes before they cascade through 12 shots and ruin your timeline. Production timelines at this scale stretch much longer. You're looking at 2 to 4 weeks from the final script to the finished output depending on how complex your narrative is and how many iterations you need to get it right. A 3-scene production with 30 shots might consume $200 to $500 in pure generation costs plus your labor time. That's still a fraction of what traditional production costs, but it's no longer trivial spending. The economics justify the governance overhead because you simply can't afford to waste credits on avoidable regenerations. The architecture here is built on reuse and versioning. You generate a scene checklist template once and then apply it to every scene. You build a master character document once and then update it as your character evolves through the narrative. You create reference pack variations once and then deploy them consistently across the shots where they apply. The more you systematize this, the faster you move. The production isn't slower because you have more shots, but rather it's faster because you've eliminated decision-making from the execution phase. Every choice is already made in the planning documents. Handling edge cases and failure modes. The architecture works beautifully until it encounters something the system didn't anticipate. These aren't failures in the model, but rather collision points between your creative vision and the technical boundaries of the stack. Learning to recognize and design around these friction points is what separates a professional production from an amateur experiment. Hand-object interaction represents the first major edge case. Your executive picks up a phone or starts typing on a keyboard, which requires the AI to maintain hand geometry while simultaneously tracking object placement and occlusion. The hands often distort or phase through the object entirely because the model struggles to reconcile two independent structures in 3-dimensional space. The solution isn't to accept the artifact, but to capture real motion instead. Film yourself performing the exact action, like picking up the phone or typing the specific sequence. Use that footage as your motion reference through the @vid1 tag. Seedance and Higgsfield can extract the skeletal structure and map it onto your character. The hand geometry comes from your real performance rather than the AI's probabilistic guess, and this approach eliminates the distortion. Character speech and facial expressions present a second edge case. The model can generate faces, but lip sync and microexpressions are computationally difficult without explicit training data. If your script requires dialogue or visible emotional reactions, you need a deliberate solution. Higgsfield includes Lip Sync Studio specifically for this problem. You provide the audio and the character reference, and the system locks the mouth movement to the phonemes. Seedance handles this through audio references, so you use the @ord1 tag to bind an audio file to your generation. The timing and emotional tone become constraints instead of guesses. This prevents the uncanny lip-sync drift that breaks immersion for the viewer. Multiple characters interacting simultaneously escalates the complexity exponentially. You now have two independent identities to maintain, while also coordinating their spatial relationship and interaction. The model struggles because it's trying to hold two separate face geometries in memory while calculating the interaction between them. Rather than fight this limitation, you should work within it. Generate each character separately in their own shots and then composite them together in post-production. This gives you precise control over both identities and prevents the interaction from destabilizing either character. Alternatively, if you want them genuinely interacting in a single shot, film a motion reference with two actors and let the AI extract the spatial relationship from that real performance. Complex environments introduce a third problem. Your character moves through an office, walks down a street, or navigates a building. The environment itself becomes a second character that needs consistency, but the model's focus is divided between the character and the setting. The solution is layering. Generate the environment separately as a static background plate so it becomes the foundation. Then layer your character's motion on top of that background in a second pass. This keeps the environment stable while giving the model's full processing power to character integrity. The character stays coherent because the environment isn't changing. Extreme lighting transitions create a fourth edge case. Your character walks from bright sunlight into a dark interior, and the face exposure changes dramatically. The model interprets this as a fundamental identity shift. The nose bridge darkens, the eyes recede, and the skin tone drops. These aren't errors, but realistic responses to lighting that look like consistency failures. The solution is reference pack switching. Create separate reference images for outdoor lighting conditions and separate ones for indoor conditions. Document which reference pack applies to which shot in your production Bible. When your character crosses the threshold from sunlight to darkness, you're also switching reference packs. The model now has matching lighting context between the reference images and the environment being rendered. Identity remains stable because the visual anchors are consistent with the lighting conditions. Each edge case points to the same principle, which is to design within constraints instead of fighting against them. You can't force the AI to solve a problem it wasn't trained for, but you can restructure the problem so it aligns with what the system actually does well. Maintain a known limitations document alongside your production Bible. Catalog which shot types consistently work, such as close-ups with neutral lighting, simple walking motion, and straight-on camera angles. Catalog which shot types are high risk, like complex hand interactions, multiple characters, and extreme motion with detailed backgrounds. Use this document to guide shot design and set realistic expectations with stakeholders. When someone requests a tracking shot through a crowded marketplace with 3 characters interacting and changing light, you know immediately that this request requires either significant simplification or substantial post-production work. The document doesn't limit creativity, but it clarifies the cost of specific creative choices, which allows you to make informed decisions upfront instead of discovering problems during execution. Building a governance framework for AI production. The gap between amateur projects and professional production isn't about the tools, it's about documentation discipline. Most teams generate shots without recording why they made specific decisions, and that creates a dangerous pattern. A month later, a stakeholder asks why the character looks subtly different in shot 12, and you have no answer. You find yourself scrambling through old email threads to find the configuration you used, but you can't reproduce that one perfect take because you didn't write down which reference images you bound to which tags. This isn't a technical problem, it's an operational one. The framework starts with a single artifact, the shot configuration document. This becomes part of your project archive, stored right alongside your final renders. Unlike the production Bible, which is a planning tool, the configuration document is a historical record created during or immediately after execution. Each row represents a single generation attempt, meaning you are documenting the exact state of your inputs at the moment you hit render. The columns matter. You need the shot number, the date, and the time. You need to know if you used Seedance or Higgsfield, and specifically which model version you ran, because different versions often produce different results. List the references used by their tags, the full prompt text exactly as it was sent, and the motion strength rating. Include an output quality score from 1 to 10, who approved the shot, and notes explaining any decisions that fell outside your standard procedure. This document does 3 critical things at the same time. First, it creates an audit trail. If a compliance officer asks how you managed character identity or if you used licensed material, you can show the exact references and prompts used for every frame. Everything is traceable back to a specific decision point. Second, it enables reproducibility. If you need to regenerate a shot 6 months later, you simply pull up the configuration document to find the original settings and apply them again. Consistency happens because you have a record of what worked. Third, it reveals patterns. When you scan down the quality column, you will see exactly where your process is weak. If shots 7 through 12 all have quality scores below 6, something systematic broke during that production window. Maybe the team was tired and started writing looser prompts. Or perhaps you switched to a motion setting that exceeded the threshold. The pattern is diagnostic. It tells you not just that something failed, but exactly where in your workflow the failure started. This feedback loop is where governance transforms from a compliance burden into a learning mechanism. Most teams track their costs but ignore their patterns. They notice they spent $200 regenerating shots, but they don't connect that spending to specific input mistakes. The configuration document forces that connection. You can calculate your first pass approval rate, which is how many shots passed on the first generation versus how many required iteration. A healthy rate is above 70%. If you are running at 50, your process needs an adjustment, and the document shows you exactly which input categories are driving those failures. The discipline extends beyond individual shots. Every iteration decision gets documented. When a shot fails and you decide to tighten references instead of reducing motion strength, you write that choice down. When you accept minor drift and plan to fix it in post rather than regenerate, you document that decision and the quality score you assigned. These annotations become institutional knowledge. When a new team member joins the production, they can read through the document and understand not just what was done, but why those specific choices were made in response to specific problems. Implementation starts simple. A shared spreadsheet in SharePoint works fine because you don't need elaborate software. What you need is the discipline to complete each row the moment a generation finishes. Some teams build automated logging into their workflow where the model API returns metadata that you capture directly into the document. This removes the friction of manual entry so the data flows automatically. The governance benefit compounds over time. Your first production might feel like documentation overhead, but by your third production, you are pulling patterns from prior work that inform shot design before generation even starts. You know that high motion shots in your style require gentler presets, and you know your reference images perform better when shot in neutral lighting. You know which combinations of settings tend toward first-pass approval. This isn't just about compliance anymore. It's a competitive advantage. You're building a system that learns from its own history. Quality standards and acceptance criteria. Your production needs boundaries. Without them, you drift into accepting work that doesn't meet your standards, and nobody on your team actually knows what acceptable means. This becomes a source of constant friction. One reviewer sees a minor texture shimmer and approves it, while another sees the same shimmer and rejects it. You need explicit criteria that everyone applies consistently. Quality standards aren't restrictions on creativity. They are the floor below which you do not operate. Everything above that floor is fair game, but you need to know where the floor is before you start approving shots. Start by defining what your character consistency standard actually is. Don't aim for an unreachable ideal. Define an acceptable range. You might decide that facial features should remain stable within plus or minus 5%. This gives you a measurable target, so you aren't just eyeballing whether a face looks right. You are measuring jaw width across frames, comparing eye spacing, and checking skin tone continuity. This requires discipline, but that discipline produces consensus. When a reviewer measures the jawline and finds it has shifted by 3%, that shot passes. If it shifts by 7%, it fails. Everyone agrees because the metric is objective. Motion quality has its own measurable threshold. You are looking for visible texture crawling in the background, limb warping as characters move through space, or temporal flicker where details shimmer between frames. These aren't subtle issues. They are the moments where the viewer stops believing in the scene. If a shot has visible texture crawling in the curtains or the character's arm warps unnaturally during a gesture, that shot does not pass. If the motion is smooth and the geometry holds, it does. Continuity across shots lives in a different category. The character's appearance, outfit, and lighting should match when you cut from shot 1 to shot 2. This isn't about a 5% tolerance. It's about whether the audience notices a jump. If the outfit color shifts noticeably or the skin tone changes without a reason, the audience feels the discontinuity. Those shots get marked for regeneration. You need the same character, the same lighting, and the same outfit, or the cut simply won't work. Audio quality has a threshold. If you're using AI-generated voiceover, clarity should exceed 95% intelligibility, so the viewer understands every word without effort. If they are straining to pass the dialogue or if the voiceover drops below that clarity standard, it doesn't pass. Your framing standards come directly from the parametric shot list. The camera angle and composition must match the specifications. If your shot list called for a slow dolly in on a 35mm lens and you see a handheld crash zoom on a 24mm, the shot does not match the spec. This is objective. The metadata in the output file tells you exactly what was rendered. Duration is a technical requirement. Your shot should match the specified duration within half a second. If you asked for a 4-second clip and the output is 4.7 seconds, that is a miss because it affects your entire edit timeline. This is measurable and non-negotiable. The approval process is straightforward. Every shot gets reviewed against these criteria before it enters your edit. If a shot fails even one criterion, it goes back to the queue. You don't lower standards to save money or time. You adjust your inputs and regenerate. This is where the discipline prevents a slow degradation of quality. Track your first-pass approval rate across the entire production. This is the percentage of shots that passed on their very first generation. A healthy rate sits above 70%. If you're running at 50%, something in your process is systematically wrong. Maybe your references are weak, your motion settings are too aggressive, or your parametric prompts are ambiguous. The approval rate is diagnostic. It tells you exactly where to look for improvement. These standards become part of your agreement with stakeholders. When a client asks when they will have finished footage, you don't have to guess. You calculate the date based on your first-pass approval rate and your historical rework cycles. You commit to timelines you can actually deliver. Human review and decision gates. The fastest way to fail is to skip human judgment. I know this seems obvious, but most teams treat generation like a machine that runs unattended. They queue up 20 shots and come back the next morning expecting finished work, but that is not how this stack operates. AI moves fast, but it isn't autonomous. Your judgment has to intercede at 3 specific moments in the workflow, and each one prevents a cascade of errors downstream. The first gate happens before you generate anything. This is shot design review. You sit down with your director or your creative producer and walk through the parametric shot list with the same rigor you'd use for a live action shoot. You're not asking whether the AI will understand your prompt, but you're asking whether the shot design itself is sound. Can a character realistically perform the action you've specified? Is the camera movement appropriate for the emotional moment? Are you asking for something that pushes the motion strength past that threshold we discussed? This is where you catch problems before they cost you credits. During shot design review, you confirm the camera language. Is a slow dolly actually the right choice for this moment, or would a static wide shot communicate the scene more effectively? You confirm the lighting approach. Is the key light from the window physically plausible for the time of day you've specified? You verify the character descriptors. Does the wardrobe match what was worn in the previous scene? Are there any continuity constraints you're about to violate by changing something about the character's appearance? You identify potential consistency risks. If this is the 5th regeneration of this shot because motion keeps breaking, the shot design itself is likely the problem, not your inputs. The second gate is first pass review. This happens the moment generation completes. The shot lands in your asset folder and you watch it. You're checking 3 things immediately. Does the character look like the reference images? Not exactly, because regeneration always involves some variation, but does it look like the same person? Is the motion quality acceptable? Are there visible artifacts, or does the motion feel smooth and credible? Are there temporal glitches, or does it hold together? If the shot passes, you approve it and move on. If it fails, you don't immediately regenerate. You document the specific reason for failure. Character drift in the jaw, tightened references for next attempt. Texture crawling visible in the sweater, reduced motion strength from 5 to 3. This documentation feeds back into your configuration document. You're building a diagnostic record as you work. The next time you encounter a similar failure, you have a pattern to reference. This gate is where you catch cascading errors. Imagine you generate shot 2 with a weak reference and it produces a slightly off model face. You approve it anyway because you're behind schedule. Then shot 3 uses that same weak reference and drifts further. By shot 5, you've got a totally different character. Now you're facing a choice between regenerating 5 shots or accepting a continuity failure. The gate discipline prevents this. You tighten the reference for shot 2, regenerate once, and move forward with clean data. The third gate is sequence review. Once you've generated all the shots in a scene, you play them back in order. This is where you catch the problems that individual shot review missed. A single shot might look consistent within itself, but when you cut to the next shot, subtle drift becomes obvious. The skin tone shifted. The outfit color changed slightly. The character's proportions look different. These aren't failures of individual shots, they're failures of the scene-level workflow. If drift is visible, you identify which shots need regeneration. Maybe it's shot 3 that's pulling everything off model. Maybe it's the transition between shot 4 and shot 5. You make targeted decisions about what to rework. This gate prevents the slow degradation of quality that happens when you're not actively watching for continuity. The discipline here is non-negotiable. You don't skip gates to save time. It seems faster to bypass review and just render everything, but you'll pay for it in regenerations. A scene with good gate discipline might need 1 or 2 rework cycles. A scene without gates might need 5 to 10. The gates aren't overhead. They're the thing that makes the process efficient. Gates are decision points. Document who approved each gate, when they approved it, and what decision was made. This creates accountability. It also creates institutional knowledge. Your next production will move faster because you know exactly where the previous one encountered friction. Human judgment isn't the bottleneck in this system. It's the safety valve. Human judgment is the mechanism that catches problems before they multiply. It's what separates professional production from wishful rendering. It's what separates professional production from hoping the AI got it right. Human judgment is where discipline produces results. It's where the entire architecture stays connected to reality. Human judgment is what makes the system actually work. It's the thing that cost is saved on. It's what matters. It's what quality comes from. It's what speed comes from. It's what control comes from. Human judgment is everything. It's actually what matters when all the tools are running. It's the thing that separates. It's what determines what actually happens. It's the moment when everything comes together. Human judgment isn't the bottleneck in the system. It's the mechanism that prevents the system from degrading. When you're facing a choice between approving a shot that's slightly off and regenerating it, that moment of judgment determines whether the next shot is easier or harder to execute correctly. Gates ensure quality. But they also require a level of trust in the process and trust in the people making the calls at each gate. Human judgment is where the architecture stays grounded. Putting it all together, a real workflow example. Let's look at how this actually works in practice. Imagine you're producing a 60-second corporate video about digital transformation. You have one executive character, a man in his 50s wearing professional attire, and the project requires 3 scenes with 12 total shots. You have a 2-week timeline to get from a final script to a finished delivery. Week 1. Planning and reference creation. On days 1 and 2, you write the script and break it down into a shot list. You need 12 shots across 3 scenes, and each one needs a clear emotional beat and specific camera movement. Nothing is left to chance here. You document the camera angle, what the character is doing, and the exact emotion you want to capture, so every shot has a clear purpose. By day 3, you open Copilot and ground it in your project assets. You feed it the script, your brand guidelines, and your color palette, along with any visual notes you already have. Instead of asking for creative descriptions, you tell Copilot to generate parametric data for all 12 shots. You want specific optical settings like a 35mm lens at f1.4 with a 5600K key light from camera left. These descriptions aren't suggestions, they are the constraints that keep the look consistent. On day 4, you build your master character document. You need 4 reference images of your executive showing the front, back, side, and a close-up of the face. Use the same lighting and the same outfit with a neutral expression for all of them. You also establish a lighting anchor, which is the specific color, temperature, and light position that defines how he looks. You document the wardrobe exactly, noting it's a charcoal gray tactical turtleneck with a fitted crew neck, because any ambiguity here will cause problems later. On day 5, you move into Seedance to create the master reference pack. You upload your 4 images and assign your tags, labeling them image 1 through image 4 for the different angles. Run a test generation with 2 simple shots to make sure the identity stays the same across different frames. If the face starts to morph between renders, your references aren't tight enough yet. You might need to fix the lighting or the background consistency before moving on, but this early work prevents hours of wasted time later. Week 1. Execution. Shots 1 to 6. During days 6 and 7, you generate shots 1 through 3. These are your establishing shots, so keep the camera static or use a very gentle arc movement. Use your parametric descriptions as your prompts and bind them to your image tags. Review every shot the moment it finishes. You're looking to see if the character matches the references, if the motion is smooth, and if the lighting hits your anchor. If everything looks right, you move forward. But if a shot fails, you adjust it while the context is still fresh in your mind. On days 8 and 9, you tackle shots 4 through 6. These are medium shots with slightly more complex motion, like a slow dolly in or a turn toward the camera. You have to watch for character consistency across these 3 shots and make sure they flow with the first 3 you already finished. Play all 6 in a row to look for subtle color shifts or changes in body proportions. This is your first real continuity check, and if you see the character drifting, you need to tighten your references or dial back the motion. Execution, shots 7 to 12, and finalization. On days 10 and 11, you generate shots 7 through 9. These are close-ups with much higher motion complexity, involving hand gestures or the character turning away and back. Your motion strength will likely push toward a 4 or a 5 here. If you filmed a motion reference, use it now, but if not, you have to prompt carefully. Tell the AI to perform a slow, deliberate turn to the left with hands visible and no fast transitions. Day 12 is for shots 10 through 12. These are your final shots, and they are usually the most demanding. You might use a crash zoom or a complex interaction between a hand and an object. You aren't trying anything new at this stage, you're just executing the techniques that have already proven to work. On day 13, you perform a full sequence review. Play all 12 shots in order and look closely at the details. You're measuring the width of the jaw, checking the spacing of the eyes, and looking for any drift in the outfit color. If the sequence holds together, you approve it. If the character looks off in 1 or 2 shots, you go back and regenerate those specific frames. Finally, on day 14, you handle the finishing touches. This is when you do your color correction, add the voiceover, and layer in the sound design. Cost estimate. The math for this workflow is straightforward. For Seedance, 12 shots with about 1.5 iterations costs $6.30. Using Higgsfield for the 6 high motion shots adds another $18 including iterations. Your total generation cost is $24.30. When you add 40 hours of labor at $50 an hour, the total comes to about $2,024. The payoff. What you've actually built here is a repeatable system. When you start your next corporate video, you'll use this exact same workflow, and it will be faster because your reference discipline is already locked in. The process is documented, so it's scalable, and it looks professional because human judgment was used at every step. You're getting a full production for about $2,000, which is incredibly cost-effective. The shift you need to make is simple. You have to stop prompting tools and start orchestrating systems. The real payoff is consistency, cinematic quality, and a professional price tag. You only get those things when you treat AI filmmaking as a strict discipline rather than a random experiment. It takes documentation and human judgment at 3 specific gates. You have to understand motion thresholds, how to use role-based references, and how to write parametric prompts. The tools are going to change. Seedance might become something else, and Copilot will eventually be replaced. But the underlying architecture stays the same. Your job is to be the architect, not just the operator. If you want to see where this is going next, subscribe. The next evolution is already on the way.